So welcome and thank you for attending the session. It's actually in three parts. I'll be presenting some of the research that we've done at ARC Advisory Group. My name is Ed O'Brien, and I work with Ralph Rio and others on EAM. Ralph works on FSM. I also do some research and writing and analysis on analytics as well. And we have with us two users who will be presenting great presentations. They'll be able to introduce, you'll have their bio on the app, but also we'll be able to introduce Odelia and Greg, welcome as well. And we have three suppliers that we'll be having in the third session that will be part of our Q&A session to give us some insight into IoT and digital transformation and asset management. So that's the plan. And what I'll try to do is I will go through this relatively quickly to give you more time to speak to the users and the suppliers as well. So we're going to first talk about digital transformation in EAM, and then we're going to talk about FSM, enterprise asset management, and field service management. And I realize in many cases they may be similar systems, but kind of sharing some of the more recent research we've had as well. And in many ways, the EAM market continues to evolve. The reason for some of the questions, just to get a sense for this change. It's really kind of an exciting time. It is an exciting time. I've been in the EAM market, pretty much for last 20 years, maybe 25. I hate to say longer as a user, and then within an EAM product supplier in various roles. And it almost seems over the last few years there's I won't say it's a tectonic shift, but there's a continual shift. And we noticed this in Ralph's report last year about some increases in EAM revenues. And we're sending out the survey pretty soon and doing other research. We expect to have an above market inflation rate for revenue. And it's kind of interesting for a mature market. You wouldn't think that this was something that would be occurring quite this long, 2.5 decades long, but it really is. There's a lot happening in the industry. We're looking at moving from more static report-based computerized maintenance management systems, or even just maintenance management systems initially, to enterprise asset management systems. And we're moving beyond that to systems that are more interconnected. As was mentioned earlier at one of the keynote sessions, the skill sets of the employees are changing as well and evolving. And the needs of the systems are internally, whether ERP systems, MES systems, really need more connectivity to the assets. And one of the things that EAM, of course, offers is, and other systems do as well, but it offers a single version of the truth or one of a select versions that includes asset hierarchies and equipment parent-child relationships, and the ability to really identify where equipment resides, where parts reside, what's their part numbers, job plans, and all these things we've been doing for many years. But now the need is to accelerate the communication of that information. So the newer EAM systems and even the way they're deployed allow for an opportunity to have shorter cycle times and quicker time to benefit. That enterprise visibility is critical, and especially in these highly competitive days. And we really need a better way to categorize, model, and plan and schedule, not just record something that's happened, but to identify what's likely to occur, when it's going to occur, and move beyond, and of course, mean time to failure and mean time to likely repairs is important, but sometimes you need more real-time information to use something more than an aggregate of when a class of assets may be ready to fail. What is happening on this particular asset? What are the vibration sensors, upper control limit systems? What are they identifying that could give us a sense for when there's going to be a failure? So we want to be more proactive, of course. And so we need access to real-time or near real-time data, as we know. And at the same time, companies are becoming aware of the benefits of a software as a service model. Being able to, in many ways, provide latest updates instant patches, and for customers, users, to be able to have either more users to maybe use work requests, but also more users to for repair information. And they also, in some cases, it might be a more affordable model because it may be more on the expense side than CapEx, but also the ability to not have to capitalize the servers and other equipment. And also expanding and using new technologies and capabilities beyond just identifying what broke and just recording it, what's likely to happen, and have an iterative process to be able to identify next time what's happening with this class of equipment, what's wrong, what caused this this failure, maybe some forensic analysis of whether or not there's something that needs to be changed in the PM process. Much more proactive information to be able to use as we move forward. And some of the new capabilities, that we're all either working with or considering, of course, mobility. Mobility's been around for a long time, but now looking at more actionable, real-time access. One of the speakers this morning mentioned the 3-minute rule. So if there's a work request or we see an alert that prompts a potential issue, so what can we do about it? How do we fix it? And is there something that we need to know about whether lockout, tagout, or what, having all that information at the fingertips of the technicians is critical. Data integration, sharing analytics. Having analytics and moving beyond, I like to think of it as 3 different levels of static reporting is more historical information, but also business intelligence, which really oftentimes is based on historic information and does provide a graphic representation of what's occurring and dashboards, but moving toward predictive analytics and being able to use data to not only look at real time or near real time, but also for future predictions. And in many cases, this is an exciting time because there are more products that are available that allow business users to use analytics, kind of the democratization of IT and the democratization of analytics. And also even for those who may not fully understand the background, not working, if you have a quant team to work with, in many cases that may not be the case, but to be able to work and have data visualization tools, it's an exciting time because then there's a chance to see trends and opportunities that we couldn't have before. So some of the new products, and they may be mentioned in a not exactly complementary way by quant teams about black box, but it can help many of us from business users to be able to do what-if analyses and then check with the IT team, hey, does this model work if I'm looking for predictive capabilities? So these opportunities provide significant opportunities and quite exciting. And augmented reality is an opportunity for all of us. I think that was mentioned by one of the other speakers this morning, and it's so true to be able to look at a visual representation of an asset, tie it in with the asset catalog that may be in the EAM system, tie it in with the parent-child relationships, identify key components that need to be either as far as a job plan or a safety a safety rule, but to be able to look at it, and many technicians being more visual, as well as if you're not sure exactly what something looks like. Very exciting times for that. And of course, using virtual reality and digital twins beyond the design stage, so our peers in other departments may be using digital twins for design stage, we can use the CAD capabilities to be able to identify what's occurring within the asset, how the asset is as built, and what we can do better as far as from a maintenance and operating standpoint. And all of this is part of this evolution. In some cases, might say revolution, but it's really more probably an evolution because we've been talking about this for quite a while, of moving beyond reactive, condition-based maintenance, even though reactive, even prior to CBM, essentially, run to fail, almost try to catch it before it fails, but many times it would be a corrective maintenance strategy, for lack of a better word. Then moving up, from the maintenance side to an automated capability that includes asset lifecycle management. And this doesn't mean that this is totally supersedes others. I mean, there's still elements of each of these in everything we do now and in the future as well. But the ability to not only look at sourcing, but also disposing, but more importantly, what did we learn from that asset life cycle to move ahead and to be able to identify how do we spec the next class of equipment? What else do we need to do? Do we need to update our preventive maintenance job plans and schedules? Do we need to change lubrication plans, et cetera? And then moving toward the asset performance management side, the intelligent, to be able to use intelligent sensors, intelligent systems, to be able to predict. And kind of the key issue here is predicting. And all of this is critical, not only because it's such a competitive environment, but also as the workforce is aging, the tribal knowledge will not be as easily communicated in an in-person way. Going back to expert systems, but the idea of being able to identify what's needed, and all of this can be provided through these updated EAM and FSM systems, EAM systems specifically in this case. So our asset management systems can be more predictive and more real time. And the evolution of these systems, as we can see, last century in many cases would be more siloed systems. Physical app development, one by one, everything having a fence around it and really not much information sharing. And the infrastructure through perhaps a data center, but all of this very much in a siloed area. Early 21st century, moving beyond what was in last century, where the genesis of the systems might have been in some cases mainframe and mini computers, where we're looking at N-tier, thin client, fat client, and thin client server, beginning to move toward more maybe hosted services that may be used using that sort of a model, and maybe some early stages of private cloud. And then today we're looking at the use of microservices and containers and cloud deployment models. More so to be able to accelerate the time to benefit. And also within FSM, field service maintenance, which in many cases may be within an EAM system, maybe in a separate system, but the being able to move more toward cloud and analytics and predictive maintenance. And in many cases, the critical path, if we look at critical path method on operations management, is the maintenance planner. And it's oftentimes has been a manual process to be able to get the information to the technician who's on the road or in the field. And many times he or she needs to have more updated information. And so as we're heading forward, moving forward, the IoT devices within the equipment, whether they are rolling stock or whether they are stationary equipment, goes through now more increasingly a cloud and analytics solution, and through still the maintenance planner or the dispatcher, and then to execute the work order. And there are three main stakeholders: users, OEMs, and dealer service providers. And this, not only software as a service, but service as a service, is becoming more prevalent in the ability to acknowledge what's occurring, but also to be able to use the knowledge of the OEM to be able to have the distributor or dealer serve the end customer more, and or to communicate to the user themselves. Similarly, into the maintenance planner or dispatcher maybe being critical path and a potential issue. Here we have issues that we may have invested quite a bit on IIoT capabilities, but the reality is in a more legacy type system, oftentimes there are missed alerts. Something happens, someone's busy, they don't get a chance to actually work on that piece of equipment, they may be on vacation. For whatever reason, there may be missed alerts, and the maintenance planner, he or she may not fully understand that and may not fully be able to follow up on that. So as we move forward toward this digital transformation stage, we look at IIoT triage and using the similar model that we've been using, but more importantly, to start using not only the smart sensors, but communication devices to be able to make sure that if something wasn't fixed when it was supposed to be, so the alert doesn't go to the old saying, dead letter office, for the alert not to die, to have the alert stay active and to re-ping that, hey, this still hasn't been done, and by the way, we're getting closer to the upper control limits, something's going to fail. So the ability to tie in the capabilities, or the results, I should say, but also to keep it, being prompting that something has to be done. And it's not just an alert, it comes up, and then if you miss it, you miss it, and which can happen in a fair number of times. And so this way, it doesn't do away necessarily with the maintenance planner, but it makes him or her more effective. And in some cases, it can work as a kind of a lights out environment that, that work request becomes a work order, and that work order doesn't get closed until the equipment is fixed. That way, all the IIoT alerts become, get acted on. So overall, just in summary, the capabilities are critical for today's. This has been true for years, but even more so now with computing power being less expensive and faster. We have an ability to execute that we haven't in the past. We've had the desire to execute, but with the new technologies and the faster capabilities, and in some cases cloud deployment models, we can do things that we've been wanting to do for years. We have a greater depth and breadth of maintenance, but beyond just static maintenance, more predictive maintenance, and to tie in the predictive maintenance capabilities that we're now using to be able to tie in what we ought to do and what needs to be done in whatever criticality mode we have. And looking at the expanded array of solutions, using IIoT and edge devices, communicating across different resources of what's needed. And likewise with field service maintenance systems, looking at dispatch and kind of supercharging dispatch opportunities and actually creating the systems themselves to be able to communicate directly with the technician, so that way no information is lost. And also to be used part of the ecosystem for the users and the suppliers and the distributors, and also the service capabilities of the users themselves to be able to work together, to be able to identify what needs to be fixed now, what do we need to do in the future to respec, and to identify, well, can we spec better next time? Do we, in our RFP, do we need to make changes? All of this becoming an iterative process. And thank you, and right now we're going to turn